Good morning. Welcome to information retrieval. Um, we're all done learning about abduction. Now we're going to see how we can use it for classification. And basically, as you can see right up here at the top, we're going to try, and try is the key word here, we're going to try and develop an email spam detector. So first of all, just to make things, we're talking about classification. And we're talking about classification with naive Bayesian inference. And for all intensive purposes, we're going to assume that we have a collection of emails, which happen to be text documents. So here are our emails, and there are a whole lot of them. And what's going to happen is if something is not spam, I'm sure you've all heard the term before, we'll call it ham. So as we go through our emails here, first of all, we could think about it this way. I don't want a clever picture there. I want a nice tabular. So here's email number 1, and here's email number 2, 3, 4, all the way up to some M. M could be some very big number. And what we do here is we classify these things as spam or ham. So maybe this is S, S, H, 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 S, H, all the way down to here like this. Okay? And immediately, the first thing that we can do here is we can now come up the probability of spam is just equal to the number of S's divided by M, and the probability of ham is equal to the number of H's divided by M. So that was pretty easy. Now, again, what we're going to be doing here is we're going to be using naive Bayesian inference. Now, thinking about the previous tapes that we looked at, we talked about things in terms of diseases and symptoms. And remember, we had this thing, we said, what was the probability of a disease given a symptom? And we said that was equal to the probability of the disease times the probability of the symptom given the disease divided by the probability of the symptom. And we said, well, gee, what if there were two diseases? What is the probability of a disease given S1 and S2? And again, this was where we made the naive assumption, which is that we assumed that the symptoms were independent of each other. And we said, well, that's the probability of the disease times the probability of S1 given the disease over the probability of S1, and then it was times the probability of S2 given the disease divided by the probability of S2. And again, if there were more symptoms, we would just keep multiplying. So this is multiplication over here. We would just keep multiplying more of these terms over here, where we would have the probability of S sub I given the disease divided by the probability of S sub I. Well, so over here, we know that whether something is spam or ham, that is the disease. What are the symptoms? And the answer is they're the words. They're the words that appear in this document. Now, something that we need to say here, and this is very important, spam is something that is purely subjective. If you have two people, what and it's possible that two people could look at the same piece of email, and one person would say that this is spam, and another person would say that this is a perfectly useful piece of email here, and it's got information that I want. So what we're doing here, of course, is this is a very specialized spam filter that we're developing here. So let's think about this a little bit further. So I've got these documents in here. D1, D2, we said there are M of them. Some of these have the label spam, some of them have the label ham. And what I can do here is I can go ahead and I can, first of all, I make a word list. So I could come over here and I could have W1, W2, all the way up to W sub n. And these are all the words that appear in D1 through DM. Okay? And then the other thing I can do here, again, I'm going to make a table. And spam and ham. And what I can do is I can make a count of how many times a particular word occurred in all of these in all of the spam documents, and I could make a count of how many times all of these occurred in all of the ham documents. Okay, so we would come over here and we would get a number here and we would get a number here, and then over here we would add these two columns up. So what I'm going to do is I'm going to call this the spam count. I'll call it the spam C of W1. And over here I'll call this the ham count of W1. And then over here, this is just the spam plus the ham count. So this is the total count. This is the count of W1. And I'm going to do this for all of the words in here. And I can come down here and I can total them. So first of all, this over here, this is the total number of words. This over here is the total spam words. And this over here are the total ham words. Everybody with that, okay with that so far? So this should very much remind you of the table that we saw in the abduction video when we were talking about the Center for Disease Control. So first of all, one of the things we could do here is we could certainly come over here and we could talk about, well, what is the probability of W1? Well, the probability of W1 is going to be equal to the count of W1 over the total number of words. Okay, and we could go ahead and we can calculate. I've lost my cursor. There we go. We could go ahead and we could calculate this for all of the W's, okay, W1 through Wn, and we'd get the probability of all of these. Then the question that we would have here is we could ask, what is the probability, and I'm just going to pick this, what is the probability of W1 given document 1? Okay, well, this would equal the number of times W1 appears in document 1 divided by the number of words in D1. And of course, we could go ahead and we can calculate this for all of the words over all the documents. So what does that mean? So that means, what do we have? Okay, so the first thing we have is we have the probabilities. We have the probability of ham, and we have the probability of spam. Number 2, we have the probability P of W sub I for any word W sub I. Okay? And 3, we have the probability of W sub I given D sub J. Okay? But the last thing I want to say is, let's come over here and look at this again. Notice over here, we also have the total number of spam words, and we have the total number of ham words. So we can calculate something else as well. We can talk about what is the probability of WI given spam, and we can talk about the probability of WI given ham. Okay? Of course, the probability of WI given spam is equal to, what did we call it? We called it spam C of WI divided by total spam words. I should say total number of spam words. And this thing over here, if I want to know what is the probability of WI given ham, that's going to give me the ham count of WI divided by the total number of ham words. Well, this, and these guys right here, these are the things exactly that I need to know if I want to try and figure out if a new document is spam or ham. So in other words, think about the following. Consider a new document arrives. And it's got some words in it, and maybe the words correspond to, in our word list, it corresponds to W3, W7, and W29. Maybe our email only has 3 words in it, and these are the 3 words. And now what we want to do is we want to calculate what is the probability that it is spam given W3 and W7 and W29. And of course, what that is going to be equal to, if we recall our Bayes formula, or naive Bayes formula, that is going to be equal to the probability of spam times the probability of what? The probability of W3 given that it's spam over the probability of W3 times the probability of W7 given that it's spam divided by the probability of W7 times the probability of W29 given spam over the probability of W29. Now in a similar fashion, so we've calculated that, now we have to calculate the probability of ham given W3 and W7 and W29. And we know what that's going to be equal to. So that's going to be equal to the probability of ham times the probability of W3 given ham times the probability of W7 given ham times the probability of W29 given ham. And we have to divide this by the probability of W3, the probability of W7, and divide that by the probability of W29. So we have to look at this quantity here, and we look at this quantity here, and we say whichever one is bigger, we would assign the corresponding class. So we make it either spam or we would make it ham. Okay. Now this is very easily extendable to more than two classes. Okay. We can extend to more classes. As I indicated to you, you could have something that sorts your emails into sports, food, cars, travel, like that. And of course, what you would have to do is when you would have to calculate the probability of each one of these. Okay, you'd have to go, so you'd have to calculate the prob of these classes. In other words, go through your email and how many of them are sports, how many are food, how many are cars, how many are travel. Then what you would have to do is you would have to come up with a word count. So you would come over here and say sports, and you would say food, and you would say cars, and you'd say travel, and you'd make a word list, W1, W2, all the way down to some W sub K. And you'd have to count how many times this word occurred in this one, this one, this one, this one. Over here, you would give the totals going this way. Down here, you would give the totals. Okay, so what you would be able to do is you would be able to count now the conditional probabilities. You would be able to calculate things like what is the probability of W1 given sports. Okay, or you could calculate the probability of W2 given cars. And remember, all of these would just be ratios. And so if I wanted to know the probability of W1 given sports, I would come over here. This would give me the total number of words for sports, okay? And this number over here would give me the total of W1 for sports. So this divided by this would give me this number right over here, okay? Then I need to go ahead and actually calculate this for each one of these different classes right over here. And then when I get a new email, I have to decide which one of these four it is. Well, I'll have four different formulas that I will have to check on and pick the biggest one out of those four. Now, there are some interesting things to say here about this. Okay? First of all, I want to say this is very, very important. So I want to say this works in theory. And the next thing I'm going to say, which is going to be very scary to you, is this doesn't work in practice. Okay? So what are the problems? Well, there are lots of them. So the first problem is what do you do? What happens if you encounter a word not already seen? So in other words, there is some new word, you've got a new email, you want to classify it, but it's got words in it that you've never seen before, meaning that you don't have any conditional probabilities for it. And that's a good question. So that is something to think about. Now, maybe you just want to assign a probability of 1/2 for all the different classes, or if there are 4 classes, assign it a probability of 1/4. Here's another question I want you to think about. Is there a difference between long and short emails? And here's the point that I want you to remember. Remember, we're trying to classify these things between spam and ham. So you could have something, well, you could have, what's the probability of ham given W1, W3, W29? Now that's an email that only has 3 words in it. So that's going to be equal to, well, we know it's going to be the probability of ham, and then we know there are going to be 3 numbers here that we multiply by, and it's going to involve the conditional probabilities of these things. But what happens here now, if I were to say to you, what's the probability of ham given W1, W2, W3, W7, W29, and a lot of other words? Okay, so we know that that's going to be the probability of ham. But now we're going to be multiplying, and every time there's a word over here, I'm multiplying times some more numbers. Etc., etc. So that in calculating this quantity over here, I'm only multiplying 4 numbers. In this quantity over here, depending upon if there are 20 words in the email, I'd be multiplying by 21 numbers. And I would suggest that if you consider this and you actually calculate some of these numbers, you're going to find that this algorithm that we've described for you here, this naive Bayesian inference, is going to show a preference for certain kinds of documents. And that preference is going to be based upon the length of the document. And we refer to that, by the way, as the bias. Okay, that this algorithm actually prefers certain types of emails over others. And that's something that I want you to think about. Now, is that to say, I say this doesn't work in practice. Does that mean that we've just wasted our time? And the answer to that is no. The point is that this is the beginning idea for developing a classifier. But it turns out that there's a lot of, there are other pieces that you need to tweak to make it work. I do think that this would be a very, very interesting term project, also a very interesting master's thesis. So I hope that some of you consider this. The mathematics to it is not difficult. If you go online, let me see if I can do this here. If I come over here and I go to Google and I go sources of spam email, Google is going to come back and there, let's see, I want, That didn't work for me. I want spam email database. So I typed in spam email database, and let me see if I can find any. Nothing is coming up here. I know that there are many, many of these out there on the internet. I'll try to take a look and update the Canvas page accordingly. Anyway, that's the end of this video. Again, an interesting project, and I hope some of you consider it.